Hi everybody, Mr. Schmidt here. In our last video, we talked about the volume of prisms and cylinders, like this rectangular prism here. We were able to mathematically find its volume, and we were able to fill it with water and figure out how much volume it had scientifically. In this video, we're going to be talking about the surface area of prisms and cylinders, and that's a little bit different because we can't fill it with water. Instead, we're going to take the object, fold it out, and figure out the outside of the entire object's area. The reason why we can't measure surface area by filling something with water is because surface area is a measurement of the total area the outside an object occupies. And in this case, it's the outside of a three-dimensional object. Okay, so if we think about what we did with volume in the last video and compare it to surface area in this video, it's because volume is the inside of the three-dimensional object and surface area is the outside of a three-dimensional object. So this entire video is only going to be dealing with the outside of three-dimensional prisms and cylinders. So let's get started. Many three-dimensional objects will have a formula that you can use to do these calculations, but a lot of times the formulas for surface area can get really tricky. So the best way to solve it can be drawing what's called a net. And a net is a two-dimensional representation of the outside of a three-dimensional object. So I have here the same rectangular prism as the one that we have up in the top left. The idea is we need to figure out the area of all outside pieces. That would be 6 faces of this prism. But it's sometimes very tricky to do that when you're on two-dimensional paper. So what we do is we take the prism like this here, and we fold it out, okay? And we think about when the shape is folded up here, the front side is here, and the back side is there. So they are 2 apart, because they end up matching. This would be then the left and right, and the other 2 matching sides would be right here. And if I get rid of the black box here, this is what the net will end up looking like. And if we think about from the shape that we have here, so this, the 3 by 5, okay, is right here. 3 times 5 for this area. But if this piece is 3 by 5, that means that this one has to also be 3 units by 5 units. Then the small one here on the side, the 2 by 3, would have to be here and then here to make them match. And the final one would be in this picture, the top and bottom, which would be 2 by 5. Here and here. Now, most of the time when my students are drawing a net, okay, they don't draw it to scale, okay? A lot of times they'll do, and this is with the pencil, it's a little bit tough, so they'll draw it like this, and they'll do here and here, okay, because it can attach to any 2 sides. So they don't draw it to scale, they just sketch it out, and then they transfer over the numbers that they have. Now, for the video, I wanted to draw a nice, high-quality one for you. But remember, you're not going to be graded on your artistic ability here. All we have to do is simply solve what we're given. So each of these are rectangles. So 2 times 3 will become 6 square units. Two by 5 will become 10 square units. And then finally, 3 by 5, for the sake of time, we're not going to label these, but they end up being 15. And all you do from here is you simply add up the total areas that were given. So in this case, we would be 15 plus 15 plus 6 plus 6 plus 10 plus 10, and you kind of run out of room a little bit. When all of that's added up, we get 30 plus 20 plus 12, so that would be 62 square units. And for every rectangular prism, you can do this the same way. You draw the net, you figure out the area of each piece of the net, you add up to find the total surface area. Finding the surface area of other prisms is exactly the same process as the rectangular prism. For this triangular prism, we have to create the net. If we think about these three middle rectangles as the outside of the prism here, and then the triangle here and here are the front and back of the shape that we are given. All we do from here is we find the area of each piece and we add them up to get the total answer. For example, the front triangles here would be 5, because that's the base of the triangle. The height of the triangle is 4 3/10, and we take that divided by 2 because it is a triangle. Okay, and if I did that calculation correctly, I get this measurement for the area of the front and back triangle. That means that this has to be the same as well. And then each of the triangles in the middle, if we think of this being 14 right here, okay, and then this length up here being 5, that would make this 70 units squared. The middle one's 70 units squared, and the final one here is 70 units squared. Most of the time, the three triangles will not be the same, but because the three rectangles, will not be the same. The reason why they are here is because this is an equilateral triangle, making them all equivalent. So if I add all three of those up, I get 231 5/10 units squared. The final shape we're going to work on in this video is a cylinder, and even though it's not a prism because it has curved edges, it is treated like a prism in that you draw the net, find the area of each piece, and add them up to get your total answer. When people draw the net of a cylinder, they usually don't have problems with the front and back because they are circles, or top and bottom, depending on how it's orientated. That creates this circle and this circle here. However, this middle rectangle is actually this piece right here because, and it's a little bit hard to visualize, if I take this piece right here and I curve it and I fold it up that way, I take this piece here and I curve it and I fold it up that way, I'm going to create the outside of the circle to then cover these two pieces here. So the reason why this looks like a rectangle is it is the outside of the circle. But we should know that the outside of a circle is diameter times pi. Then this piece right here is the height of the rectangle. So the middle one has an area of diameter times pi times height. A little bit tricky to get used to. Circles, by definition, then have areas of radius times pi, just like they have in every other time you've worked with a circle before. And all we have to do is solve each piece to get the total area. Now, the circles are going to be 3 2/10 times 3 2/10 times pi. For the first circle, 3 2/10 times 3 2/10, times pi. For the second circle, half of 6 4/10 is 3 2/10. The middle one's a little bit trickier, though, because the diameter is 6 4/10. The height is 13. So we get 6 4/10 times pi times 13. Now, to save us some time, I have the calculations already written out here. So the first circle is 32 1700ths. Second one is also 32 1700ths. And the middle rectangle is 261 3800ths. These are all estimations because we do not know the exact, or we cannot calculate the exact number of pi and still round to decimal places. So these are all about. So when we write the surface area, we're going to write with the about equal sign, and we just simply add up the three things that we had. And when we calculate this out, we end up getting an about equal to of 325 and 72 hundredths units squared. Once again, two-dimensional measurement, so we need to label it in units squared. So to finish the video, a couple small things to remember. Surface area is the total area occupied by the outside of a three-dimensional object. Volume is the inside. You should draw a net to understand which shapes the surface area occupies. So are you dealing with circles, rectangles, triangles, so on and so forth. Add up the total areas of the net. So find the areas of each piece, add them up, and remember that area is two-dimensional, so it should be labeled in square units, square centimeters, square feet, square inches. I hope that was a good start to understanding surface area, but if you have any questions, make sure to let me know.